Question 9 gives us a relationship between P, the amount of plastic measured in millions of tons per year, and T, the number of years after 1980. Part A then asks, show algebraically that the graph of log 10 of P against T should be linear. First, let's take logs of both sides. Using the rule for addition of logs, we can split up the right-hand side. Next, we can bring down the power inside the second log. Log base 10 of 10 is just 1, leaving us with the final equation, which is linear in T. Question 9b asks us to complete the table, filling in the missing values of log base 10 of P. From the table earlier, the value of P for T equals 15 was 156, so we take log base 10 of 156 for our first value. And the value of P for T equals 25 was 260, so our other missing value would be log base 10 of 260. 9b part 2 asks us to plot the graph of log base 10 of P against T and draw a line of best fit for the data. Plotting our table we produced from the last part produces a straight line like this. Question 9c asks us to show that the value of k from our model is approximately 0.02 and find the value of a. Let's recall our equation from part A and compare it to the standard equation for a straight line. After comparing, we can see our effective y variable is log base 10 of P and our effective x variable is T. This means our effective gradient would be k and our effective y-intercept is log base 10 of A. Measuring our gradient gives us a value of 0.02 for k, and the y-intercept from the graph is around 1.875, which would correspond to log base 10 of A. Reversing the log gives us a value of A of around 75.
9d asks, using the model with k equal to 0.02, predict the number of tons of annual global production of plastics in 2030. First, let's recall the model for the millions of tons of plastic produced each year from 1980. Now if we plug in a value for T of 50, this gives us 750 million tons produced in the year of 2030. 9e asks us to use the model to predict the first year P exceeds 8,000. Setting P equal to 8,000 gives us the following. Dividing by 75, logging the equation. Solving for T gives us a value of 101.401, meaning it will take just over 101 years to first exceed 8,000. This means we would first exceed 8,000 in the year 2082. 9f asks why we shouldn't use this model to extrapolate into the future. The answer is you should never extrapolate a model past the range of the data the model was used for.